Everyone was holding their breath for a massive, world-changing Gemini Pro release.
Yeah.
We always expect the paradigm shift.
Oh, absolutely. The big flashy drop.
Right. But instead, Google slipped a highly tactical, almost boring update under the door. And ironically, it might be the most important thing they've released this year.
Yeah, it really is the ultimate pivot from hype to utility. I mean, we've spent the last few years obsessed with AI that can, write a symphony.
Or pass the bar exam.
Exactly. But for actual software engineering, we just needed something that works reliably at scale.
Well, welcome to the Deep Dive. Our mission today is unpacking Google's July 21st, 2026 release of the Gemini Flash series refresh. We're going to figure out exactly what this means for your daily work.
So we have 3 specific models on the table today.
Right.
There's Gemini 3.6 Flash, there's the blazing fast Gemini 3.5 Flash-Lite, and finally there's the heavily restricted Gemini 3.5 Flash Cyber.
The restricted one is fascinating.
It really is.
Yeah.
And the goal here is to help you figure out exactly which model fits your architecture and why this feels like a highly calculated strategic move before Gemini 4 eventually drops.
So let's start with the flagship of this release. This is Gemini 3.6 Flash.
Yeah.
Like we said, it's not the pro model everyone wanted.
Yeah.
But honestly, I think it's the most practical upgrade we've seen in a while.
How so?
Well, because it directly attacks the unit economics of AI.
That is the perfect way to look at it. Gemini 3.6 Flash is the workhorse. It sits right in the middle of Google's lineup. It balances coding quality, document understanding, and multimodal work. But the entire architecture is optimized to drive down the cost of complex agent tasks.
And that focus on cost is vital for anyone actually building software right now.
Yeah.
2-sec silence. People forget how expensive AI agents get in production.
Totally.
An agent doesn't just answer your prompt once. It loops.
Right. It iterates.
Yeah, it checks files, it makes a plan, it writes code, and then it checks its own code.
And if a single debugging task takes 20 background steps?
Which happens all the time.
Exactly. And you're paying top dollar for every single step, your profit margins just vanish overnight.
Yeah.
You literally cannot build a sustainable SaaS business if your back-end AI is bleeding cash on every loop.
Which brings us to the most interesting mechanism in the source material. Gemini 3.6 Flash uses 17% fewer output tokens overall compared to 3.5 Flash.
Right.
Now, I want to unpack how that actually works. Output tokens are the expensive ones, right?
They are. Generating a token requires significantly more compute than just reading an input token.
Makes sense.
So by reducing the output token count by 17%, Google didn't just lower the price on a pricing sheet, they made the model structurally more concise.
Like, it gets to the point faster.
Exactly.
And it gets even more extreme when you look at coding. On DeepSWE, the model uses up to 65% fewer tokens.
That's a huge drop.
Let's define that real quick for everyone.
Yeah.
DeepSWE is a benchmark for complex software engineering tasks.
Right. And to give you an idea of what that benchmark entails, it's not just asking for a simple Python script.
No.
It's asking an AI to navigate a massive legacy codebase, find a bug, and write the patch.
Wow.
Yeah, so 65% fewer tokens on a task like that. It completely changes the math of running a coding agent.
The pricing structure really reflects this push for high-volume utility, too. We're looking at $1.50 per $1 million input tokens and $7.50 per $1 million output tokens.
It's a massive shift. They basically want you to build autonomous systems that run continuously.
I have to admit, I still wrestle with prompt drift myself.
Oh, don't we all?
You set up this beautiful, complex prompt, and by the 4th or 5th iteration in the loop, the AI just loses the plot completely.
It forgets what it's doing.
Right. You have to scrap it and start over. Saving tokens on those inevitable, frustrating retries is an absolute lifesaver.
And beyond saving money, fewer tokens to generate physically means the model finishes its thought faster.
Oh, right.
So you get lower latency on top of the cost savings.
There's also a major security component baked into this 3.6 upgrade. The source notes it features new frontier safety safeguards. Yeah, this is critical.
These specifically target CBRN. That stands for chemical, biological, radiological, and nuclear risks.
Right. It also specifically targets cyber offense misuse. They are actively trying to stop bad actors from using the model to automate network exploitation.
But the tricky part here is the balance. 2-sec silence. We both know security safeguards usually make models incredibly annoying to use for legitimate work.
Oh, definitely.
You get those false positive refusals where the AI apologizes for not being able to help you write a basic bash script.
Yeah, the dreaded "I cannot fulfill this request." But Google's documentation claims this model resists actual jailbreaks without those constant, annoying refusals.
That's refreshing.
It is. It's trained to understand the context of your legitimate developer environment much better.
I want to circle back to that massive token reduction, though, because it raises a critical question.
Okay, shoot.
If it uses 65% fewer tokens for coding, is it actually thinking less, or is it just communicating more efficiently?
It's communicating more efficiently. The model cuts out the conversational fluff. Okay.
It stops writing, certainly I can help you with that code, and just outputs the raw diffs.
Nice.
And we know it isn't thinking less because its core reasoning scores actually went up. It hit 63.9% on MLE bench.
Which is a solid jump in machine learning engineering tasks.
Exactly.
Got it. It edits itself better, saving us money on every single output.
It's all signal, no noise, which is exactly what developers have been begging for.
Okay, so 3.6 Flash is a fantastic, precise workhorse. But what if I'm running a customer support pipeline that gets 10,000 pings a minute?
That's a different story.
Yeah, even at $7.50 million output tokens, I would still go bankrupt.
And that is exactly why Google quietly dropped a second, purely volume-driven model alongside it, Gemini 3.5 Flash-Lite.
This is the budget speedster.
This model exists for one singular reason: raw throughput.
The numbers here are just wild. It hits a blistering 350 output tokens per second.
To put 350 tokens a second into perspective, you are basically watching a short novel generate in under a minute.
That is fast.
It's so fast that to the end user, the response feels instantaneous.
And the pricing drops completely through the floor. It's dealer 30 cents per $1 million input tokens. Output tokens are just $2.50. 2-sec silence. Whoa! Beat. Imagine scaling to 1 billion queries without bankrupting your startup.
That unlocks entirely new SaaS business models that were financially impossible yesterday.
Right.
Teams building internal search pipelines, scraping tools, or real-time gaming NPCs can finally run thousands of background tasks every hour without the latency and costs stacking up aggressively.
But cheap doesn't automatically mean dumb.
No, not at all.
The data shows it actually beats the older Gemini 3 Flash in some surprising areas.
Yeah, it scored 54.2% on SW Bench Pro, and it hit an impressive 74.0% on Always World Verified.
Always World Verified is a fascinating metric. That's a computer use benchmark.
Right.
It measures how well the AI can physically navigate a virtual desktop environment.
And Flash-Lite actually comes with a built-in computer use tool. Yeah, it's designed out of the box to interact with websites and apps. It can click buttons, read DOM elements, and navigate browser environments.
That's a staggering amount of capability for 30 cents a million input tokens.
It is.
But the most unique feature mentioned in the sources is its adjustable thinking levels. You can actually dial this cognitive effort up or down.
It gives builders incredible granular control over their API bills and their latency.
Wait, but if I lower the thinking level, aren't I just intentionally making the AI dumb? Beat. Why would anyone manually lower the thinking level if the model is already this cheap?
Because in high-volume, simple background tasks like extracting a date from a receipt, you don't need deep philosophical reasoning.
Sure.
When you lower the thinking level, you are literally telling the model to skip its internal loop of self-correction.
I see.
It bypasses the chain of thought scratch pad. It just grabs the data and runs.
Makes sense. Lower thinking means faster reflexes for simple, repetitive background tasks.
You don't need a chess grandmaster to sort your mail. You just need someone with fast hands. Reducing that internal processing drops the latency to almost nothing, making the system ultra-responsive.
Sponsor.
So having explored the heavy lifter in 3.6...
and the speedster in Flash-Lite, the real question is application. How do these actually fit together in a real-world software architecture?
The secret isn't picking one model over the other.
Right.
That's a trap a lot of developers fall into. The real secret is using them together in a master worker setup.
We're talking about agent workflows here.
Exactly.
Let's define that for clarity. Agent workflows are AI systems that run multiple steps automatically to solve problems.
And building a resilient workflow is all about assigning the right brain to the right task. You want to match the cognitive overhead to the specific job.
I like to think of this setup like stacking Lego blocks of data, beat. But to push that metaphor deeper, 3.6 Flash is the master builder holding the instruction manual, while the Flash-Lite models are the hands just snapping the repetitive parts together.
That's a great way to visualize it.
So 3.6 Flash acts as the master agent.
Right. The master agent's job is understanding the big picture goal. It takes the initial user prompt, breaks that massive task into smaller, manageable microjobs, and writes the structured JSON instructions for the other models to follow.
And then,
Crucially, it reviews the final decisions.
meanwhile, Gemini 3.5 Flash-Lite acts as the worker agent. It's the muscle doing the heavy lifting in parallel.
Yeah, the worker agents take those JSON instructions and execute them. They generate the drafts, they run the quick web searches, they do the high-volume data extraction.
Stacking the Lego blocks, you use the cheap, fast blocks for the foundation, and you save the complex, expensive master builder for the detailed quality control on top.
You ensure you only pay for high reasoning when it's absolutely necessary.
Let's trace a real-world example from the sources to see how the architecture physically operates. Say you are building an internal research tool to scan corporate filings.
Okay, so you give the system a massive 300-page financial report.
Right.
The master agent, 3.6 Flash, reads your prompt. It realizes it needs to extract Q3 revenue numbers, check historical trends against last year, and summarize any new legal risks.
But it doesn't do all that reading itself. It farms it out.
Exactly. It sends 3 separate, highly specific prompts to 3 Flash-Lite worker agents simultaneously.
And because they are moving at 350 tokens per second, those workers hit the massive document, pull the data, and return it almost instantly.
And they cost absolute pennies to run.
Yeah.
The workers hand their raw findings back up the chain to the master agent. The master agent then synthesizes the final report using its higher reasoning to ensure the narrative actually makes sense and answers your original prompt.
But there's an obvious risk here, right?
What's that?
If the cheaper worker agents hallucinate on a task, can the master agent reliably catch those mistakes?
The data suggests it can, provided your system architecture is solid. Gemini 3.6 Flash has the advanced reasoning bandwidth to act as an evaluator. It can cross-reference the worker's output against the original text to filter out the weak or incorrect data.
So the smarter model acts as a strict quality control filter for the workers.
It is a hierarchical management structure built entirely out of AI models communicating with each other.
Which is incredibly efficient. 2-sec silence. So we can use those first 2 models to build our Lego castles. But there is a third model Google released in this update.
Oh, yes.
And this one is strictly locked behind closed doors.
This is the restricted enigma of the July release. Gemini 3.5 Flash Cyber.
You cannot find this in the consumer Gemini app. You cannot just call it up on an API for your personal coding project.
No, it runs exclusively inside CodeMender, which is Google's internal AI code security agent.
The sources explain this model is fine-tuned specifically to discover and repair security vulnerabilities.
It's a highly specialized digital detective. Multiple Flash cyber agents can work together in that same master worker architecture we just talked about. They inspect massive code bases, tracing data flows in ways human engineers simply can't keep in their working memory, hunting for structural weak points.
But the access is severely locked down. It is restricted only to governments and trusted partners in a closed pilot program.
And we really have to talk about the dual-use nature of this technology.
Dual use. Beat. That's a terrifyingly clinical term for what we're actually discussing.
It is. The fundamental reality of cybersecurity is that if an AI is incredibly good at finding and fixing vulnerabilities in code,
it is mathematically just as good at exploiting them in the wrong hands.
Exactly. A tool that tells you exactly how to lock a complex vault door can also show someone exactly how to pick it.
Yeah.
If a malicious actor got raw API access to Flash Cyber, they wouldn't use it to secure their own code. They would point it at open source repositories and automate the discovery of zero-day vulnerabilities at massive scale.
They could find the cracks in the global software supply chain before the maintainers even know they exist. 2-sec silence. But I have to push back on Google's logic here. Does locking this model away actually keep us safer? Or does it just slow down independent security defenders?
That is the core debate in open source AI right now. Keeping it restricted definitely frustrates independent defenders.
Right.
But Google's calculation is that releasing it openly would arm malicious actors overnight. A rogue hacker could use it to automate massive zero-day cyber attacks before the defense community had time to patch the holes.
Right. Keeping it restricted stops hackers from automating massive zero-day cyber attacks.
Google is taking the cautious route. By deploying it only inside controlled environments like CodeMender, the outputs and the targets can be strictly monitored.
It's a fascinating, slightly chilling glimpse into the future of cyber warfare. The battles of the next decade won't be fought by humans typing on keyboards in a dark room.
No, they won't.
They'll be fought by swarms of specialized security models attacking and defending code bases at machine speed.
Which is exactly why the restriction makes sense for now. The potential blast radius of a rogue security AI is just too large for public release.
Let's slowly pull these threads together. Beat. We've looked at all three parts of this July 2026 release.
And a very clear picture emerges about Google's strategy.
This update is not about flashy, generalized intelligence.
No, it's about pure, practical utility and unit economics.
Google is handing developers highly efficient, specialized tools. You get a brilliant master builder in 3.6 Flash. You get a blazing fast, cheap worker in 3.5 Flash-Lite. You can finally use them to run automated systems affordably.
And they are clearly doing this to buy time. They're giving builders the precise tools they need to optimize their current architectures, while Google finishes cooking the eventual massive release of Gemini 3.5 Pro and Gemini 4.
It's a bridge, but it's a structurally vital, very useful bridge for the industry.
My recommendation to anyone listening today is to deeply audit your current AI workflows. Look at where you are spending money on API calls. You are almost certainly overpaying for reasoning on simple tasks. You should absolutely try building a master worker setup with these two new models. The efficiency gains are just too massive to ignore.
2-sec silence. It makes total sense for the bottom line. But it does leave me thinking about the underlying structure we are building.
How so?
If our top-tier AI models are officially transitioning into middle managers, whose main job is to delegate tasks and oversee swarms of cheaper, faster AI workers, what happens when those worker models become perfectly capable of managing themselves? Where exactly will you and I sit in a fully automated AI hierarchy? Out Tiro music.